Hello everyone, and welcome to my talk about generating VM-based test environments on the fly. My name is Christoph Wolf. I'm an advanced software test architect at Medell. So, uh, what's the topic? First of all, um, we want to analyze which problem we want to solve. Then we will discuss why we are using VMs to tackle this problem, and then also in particular how we are exactly doing it. And at the end, there is a short demo. So, which problem do we want to solve? Um, our problem is that Medal is working in a very highly regulated field, namely medical devices and medical device software, in particular hearing implants and other implants. So we have very strict regulatory requirements and standards to adhere to comply to. And not only that, but there are also other standards like cybersecurity standards and so on that we all need to fulfill to be able to go to market. In our particular case, also, we are producing a wide variety uh, of software, medical device software. And in particular, what I want to focus on in this talk is Windows desktop applications. And another thing is that we want to do is we want to ensure high quality using test automation. Meaning that in our particular case here, we want to fully automate or as far as possible automate tests with respect to Windows desktop applications. Could be hardware integration tests, but could also be automated UI tests. Unfortunately, for Windows desktop applications, it's not as easy. It's not so easy as just simply spinning up containers. So we need to do something else. And for this, we will be using headful test VMs. Um, Not only do these solve the problems from before, or more or less the automation part, but additionally, we get the following for free. So traceability and reproducibility, security compliance, monitoring, fully automated workflows. Very important also is that we can easily switch the underlying hypervisor so that we don't have any lock-in. And we want some easy CI to combine all of this. So in the end, as little manual intervention as possible. But why are we using VMs? The problem here is that in our case with Windows desktop applications, headfulness is a hard requirement because such applications and also various third-party software require interactive user sessions. So meaning headful sessions because Windows cannot fully render so UIs, for example, application UIs from not non-interactive sessions, and it requires a running display. So this will be a point that I will touch on in just a second. Next thing is that regulations require realistic test systems so that our test systems um, emulate as much as best as possible the actual environments that our customers in the clinics will be running. Then the bare metal machines are security liabilities. This also ties in a little bit with the first bullet here. where you would have to have a running physical display to be able to have these fully interactive sessions with the full UI rendering. And this, of course, is a security liability. You would need to have auto log on there and so on. So anyone could just tamper with the machine, and we want, of course, to prevent this. Just as an example, there are also other examples or other problems that we can prevent using VMs. And another thing is that we need to have is uh, if we interact with pluggable hardware, so for example, doing hardware integration tests or for interactions with the application together with hardware, we need to ensure proper interaction with those. And the nice thing is that headful VMs solve all of those concerns and even more. So we have virtual screens, no need for a physical screen anymore. We can easily automate or parallelize our automated UI tests. We have built-in hardware switching and multiplexing, which is nice for switching between uh, test cases, for example, certain hardware. Golden image that we use for the stuff ensures that we always have a reproducible state. Then we automatically get on-demand configuration of provisioning for each test run, more or less. Let's say I want to test my application with a different screen resolution, then I can just configure this when running the VM to automatically have this different resolution to see how the application behaves using this provisioning. And we automatically get built-in retention and snapshots. So how are we doing this in particular? What is the toolchain that we are using for this? Yeah, it's pretty easy. We're using Packer and Vagrant. And these also give us all these points for free that we had right in the beginning. So traceability, security compliance, ECCI, and so on and so on. So when we get started here, first we want to use Packer to create our golden images for the VMs. And here is an example of a source block in an HCL file for Packer, a Packer template. And here we simply focus on, in this case, this example, the source block for a for the VirtualBox provider for installing or for creating a VirtualBox machine from a Windows ISO. No example. Here we have some provisioning, some real more or less hardware provisioning, like a number of CPUs or that USB should be piped through. And here in the middle, very important is that we set headless to false, meaning that we really have a headful VM. Maybe something that I should touch on here is also the floppy files that we provide here, which is just this array here, where we provide an auto unattend file, which will be used for installing the Windows ISO in an automatic manner. And we also install OpenSSH because I usually prefer for Packer and Vagrant to use the SSH communicator because I feel it's the most reliable. And to also stay consistent with other systems. Then here in the same Packer template, we have a build block where we use this previously defined source to build our VM, our VirtualBox VM. Here we have some additional provisioning, namely things that I need for the automated UI tests in particular to work reliably. Things like disabling of the screensaver, disabling hibernation, disabling toast notifications, or in particular also installing the WinApp driver, which we will be using as the UI automation backend. And here at the bottom, there is this Vagrant post processor, which simply generates a Vagrant box file out of the generated VM artifacts. And executing Packer build on this template will generate our Vagrant box, as you can see here at the bottom. It's simply this box file here that we can then add to a Vagrant environment and run it. We can also do other things like install any plugins that we need using Packer init. We can validate the Packer template and so on. There are quite a lot of commands that the Packer CLI offers. As a next step, we then will be using Vagrant to generate our short-lived test VMs for each run. And such a Vagrant file could look something like this, where at the top here I have a few variable declarations that would be needed in the blocks below, where I here more or less use the simple trick of just reading out environment variables, and if they have not been set, then I will just use some sensible defaults. Then here we have the provider block. Again, this should be a VirtualBox VM. And important here is the GUI property, which is set explicitly to true, so that we are running a headful VM. And also other things like you can see here that I am again using SSH to communicate with the VM. And also in the provider block here in particular, this is where I set my provisionings, hardware system provisionings on a per run basis. So for each run, I can simply override the configuration from before. At the bottom here is something important for the demo that I will be showing then, where I have a simple file provisioner which copies some source file to some target. This I will be using to copy a demo binary, demo executable into the VM, which I will then execute to show some UI automation in there. And then we want to simply up our machine. So we want to start it, want to run it, and do any additional provisioning as we have defined in the Vagrant file. And for this, I simply use the Vagrant up command, and then Vagrant will do all the spinning up of the VM, any hostname configuration, network configuration, port forwarding, and additional provisionings that I've set. Also a lot of other commands here, just a few examples that I'm often using in my CI pipelines. But yeah, the Vagrant CLI offers quite a lot more. Our general CI workflow looks then something a little bit something like this. If the golden image, so in our case the Vagrant box is not available yet, we build it using Packer, and then we deploy this Vagrant box to the target VM host and add the box using the Vagrant box add command. As a next step, we up the VM and monitor its status. Then we execute our tests on the VM using the CI systems agent system, whatever that is. And at the end, we destroy the VM. Or we could also back it up, do snapshots, also during the tests themselves, the test run, to have even more easily reproducible states. And now it is time for the demo. Okay, so let's get started. I have all of this code in my IAC collection repository on my GitHub. You will see the link at the end of the presentation. I have things in there like the Packer templates that I've been using for this stuff. So scripts, the Windows installation file for the automatic installation, Vagrant files, and also importantly for this demo here, some tool, which is a simple C# based tool for executing some UI automation, just to show you more or less what the CI agent would be doing when running tests. So at the start, I'm executing WinAppDriver, which was this executable that I have provisioned the VM with during Packer build. This is then used as the actual UI automation backend. I will run this automation against the Windows Calculator app that is built into the system. And then from using this, let's maybe also start Vagrant app while we're doing this. For this, then I'm also using this Appium WebDriver API to interact with WinAppDriver for the UI automation. So it's more or less the automation client. And for this, I'm just looking for the calculator app itself. I'm getting the automation elements on the client side by identifying the actual UI elements using certain things like here I'm retrieving various buttons of the calculator app, namely the #1 button, the plus button, and the equal button, and I'm also attempting to find the results display of the calculator. Now the simple script is as follows. I'm just calculating 1 plus 1 and pushing the equals sign, the equals button. Then from this result display, I'm retrieving the actual value that is in there. So in our case, we would expect this to be 2, of course. And then I'm adding some additional output, which exactly tells us the result that has been displayed. Additionally to this output, WinAppDriver itself will also output its std out and stdr to the console that is being started by this app. And at the end, we will have this output here. And then at the end, I simply dispose of the driver, so this automation session here, and the WinAppDriver process. Now, if we take a look how our VM looks, it is almost done. Vagrant is just doing a few more minor things regarding its more or less its automation that it uses. So namely the SSH interactions, setting where do we have it? Setting the name of the VM, so the host name, forwarding ports, mainly for SSH interaction, but could also be used for other things. Here again, it's just doing a few more SSH configurations. And next we should see that it provisions the VM with this demo executable that I have built beforehand. So this will just take a second. So as you can see, this should just be a simple representation of what happens when we execute our CI workflow or pipeline to create such test VMs. And here the nice thing is that, well, as I've shown before in the CI workflow slide, we can simply start now this Vagrant box, this VM, because we have already deployed it to our VM host. Vagrant up more or less does all the rest there. So we should also soon be seeing that the file is being deployed. Yes, here is the binary that we are using then for the demo. And as soon as this is done, I can easily simply execute the demo from inside there. So usually with the pipeline, this would be done automatically by the agent that is running on this VM. So this could also be something that we can provision during the Packer build step or on our Vagrant file. So this is done, and now the VM is up and fully running, and the demo executable is here. So now we simply execute this. And now this should show the automation that would be running then. So the automation will now start the calculator app and do all these interactions that we have configured. And as you can see, the result is 2, of course. That's pretty much it already. So this can be used, for example, for automated UI tests, hardware integration tests, or any other tests that would need such an environment. And at the end, we can destroy the VM. So let's see. Should now be closed soon. So this would be usually the last cleanup step that the pipeline does. And we're done. And at the end here, I want to say thank you to everyone, also in particular to HashiCorp for having me here. And I hope that learned something here that could be useful also for your test automation of desktop applications. And for the demo that I provided here, you can simply have a look at my GitHub that I've shown here. Thanks again, and bye.